Oh, I'm really that good. The smartest person. Anyway, thank you for that kind introduction. I hope you all had a good lunch. It's 1 o'clock. It's my pleasure to welcome you back to NPA 15, that's Natural Philosophy Alliance, 15th conference at the University of New Mexico. And it is with great privilege that I come year after year after year to present, not because the mainstream physics doesn't accept my ideas, which of course they don't, but I will come anyways. This is how much confidence I have in our ability to handle this. Now, before I get started, I want to make sure that you appreciate that I had my full paper on the NPA 15 website, and for just few people maybe who didn't bother to read, print, or even care, I brought a few copies and put them here today, hard paper copies. But you can get it both either at my website or at the NPA 15 website, plus some videos and other stuff that comes with it. So with this, I'd like to get started. Some of you have been to my presentations before, so you might see some familiar slides, even though I used overhead projector last time, and this time I'm using PowerPoint, so they would look a little different, and some of them I just copied from the overhead, some I didn't, but those of you who have seen my overhead animation, you cannot really quite reproduce that animation in PowerPoint the way I do it in overhead projector. So here we go. Sometimes I take pride in writing some poetry, and this is one of my simple attempts at it. And this basically gives the theme of my presentation also. And that's basically saying, and I'll read it with you because it is kind of interesting and sets the tone for the rest of my presentation. There is but one reality created by but one God. You may not know it, I may not know it, she may not know it, Nobel laureates may not know it, even Pope may not know it, nobody may know it except God. But no power on earth can change the rugged reality that there is one reality in here and out there for all, created by but one almighty God of us all. Our perception of reality may be our reality. And from that point of view, we have as many realities as 6 billion people living on earth. But absolute reality of God, it was not, is not, and cannot be, regardless of what your perception is, because our perception is never, never under any circumstances in 100% agreement with God's reality. Now, many of you know that I have had a corporate life for many years, and every time when I went to corporate life, there were layoffs and rumors of layoffs, and it worried me, because if they laid me off, then I don't have any place else to go, and all of a sudden I don't have 6 months or years of food storage and other things that you need to pay your mortgage and support your kids and car. So it used to worry me. So finally I said, no, before they fire me, I'm going to have a backup plan, my own company, start my own company part-time and so on, and I did. And that was 20 years ago. And my company has been growing by leaps and bounds. And fortunately, today I can happily report to you that there has never been a layoff in my company, and you will appreciate that why as you examine the organization chart of my company. Now, this may be tongue-in-cheek, but it does obey all of the state, federal, and city laws. The only criticism I get of my organization chart is that I'm lacking affirmative action. There are no women, there are no blacks. I said, well, you can't please them all. So there we are. So let's get right into the presentation with some of the background. And this is the background. In a way, this is one of the assumptions I have. I have very few assumptions, but the assumptions that I have are so critical that nothing will make any sense to anybody if they disagree with my assumption. My assumption is, number one, there is a God. And if you don't believe that, If you're Richard Dawkins or many hundreds of other atheists, chances are you will not be able to connect to my presentation. My second assumption is that this entire universe has a medium called virtual light medium, universal virtual light medium. Not to be confused with ether, not to be confused with physical light, because physical light is subject to absorption, reflection, refraction, scatter, break up into colors through prism, and so on. This virtual light has none of those properties. So, and I'm assuming that virtual light medium exists every place, inside the atom as well as outside every atom. And of course the space inside the atom between the nucleus and the electrons is so much greater compared to the size of the nucleus and the electrons that it's mind-boggling. And if I had more time, I would lead you through this slide and convince you by roughly scales how much bigger that space is. But for now, you'll have to take my word for it, that the space between nucleus and the electrons is at least as great as the space between a strawberry and our solar system, or at least the sun. You know what I mean? In a huge scale. So anyway, so those are some of the things, and you can just say, you can reduce the quark to a cherry, then the atom alone will be the size of the Earth. So the rest of the space is vacant in between. By vacant, I mean full of universal virtual light medium.
You know how big the quark is?
Quark is very small.
But how do you know how big it is?
I don't know, but I know from the standard model that it is very small, much smaller than the nucleus, and so on. You know,
Smaller than a neutron or a photon?
small both. I think smaller than both.
I agree with you, but
Anyway.
I wondered if anybody knew how big it was.
No, but I mean, all I'm trying to do is the relative space rather than their masses. This is, for example, I mean, I won't have time to convince you of everything we're going to convince, because number one, it's sort of too outlandish. You know, I mean, you will have to come to a conclusion that so many people have been so wrong for so long, or this crazy fellow is wrong. And it's a no-brainer. I mean, I immediately come to the conclusion, I'm the crazy fellow alone, I'm wrong. How can so many people be so wrong for so long? But I'm going to convince you, at least try to convince you, that make a record of this day that this crazy fellow stood up in front of us, said these crazy things, and we did not agree with any of it. But at least there will be a paper trail, which lawyers love, you know. Lawyers love paper trail. So I want to leave a paper trail today that you heard for a whole hour a crazy fellow, far more crazy than Einstein, and he even thinks that he's correcting the errors of such icons of science as Aristotle, Galileo, Sir Isaac Newton, and Einstein. That's over 2 millennia. And everybody else in between also who failed to correct the errors of Aristotle and Galileo and Newton must also be wrong, if I'm right. So let's move on. This is, for example, UVLM is capable of explaining everything. This is my little attempt at explaining, which the physics textbooks do a very poor job, or no attempt at all, in explaining why is dynamic friction less than static friction. My UVLM explains that. Anyway, this is a picture that I copied from a book, and it says basically, a famous statement of Archimedes. He says, give me a place to stand and a lever long enough and strong enough, and I'll move the world. And here's the place somebody has made for him. And imagine he has some kind of a lever under this earth. This is the whole earth. And he's standing outside the earth. My question to you is, what's wrong with this picture? Tell me, there's something drastically wrong with this picture. Archimedes is going to move the earth. And I'm saying there is something fundamentally wrong there. No, he has the place to stand. The picture shows the place to stand.
The place to stand is move or
The lever,
something else.
He has the lever. See, the lever is going from here to there. In other words, I'm asking for something new that's wrong with this picture, not what you already know.
Whoever has to be on something.
Yes, but that also is implied in his statement. I mean, you're just repeating what the statement says. That give me a lever long enough and strong enough and I'll move the world.
Given a place to stand.
He has the place to stand.
But where is that place?
That doesn't matter. At least you know that. What I'm saying is, you got to find me something wrong with the picture that the physicists don't already know. They already know about this place to stand, that it doesn't exist.
There's no bird sitting on the egg.
Anyways, it's not an egg, this is Earth. But never mind. If you give up, I'll give you the answer. Huh?
There's no atmosphere for him to breathe.
It doesn't matter. Let me tell you what I think is wrong with the picture. What's wrong with the picture is that Archimedes cannot move the Earth because the Earth is already moving. The best he can do is either speed it up or slow it down. He cannot move something that's already moving. Not only the Earth is moving, but everything in this universe is moving. You say, well, how can everything be moving? We are sitting quietly in our chair. No, you're not sitting quietly in your chair without moving. You are at a dead end. Pull the chair underneath from you'll fall to the floor. Pull the floor away from you, you will fall to the lower level. Drill a hole to the ground, to the center of the earth, you will keep falling. In other words, you will keep moving if it weren't for the dead end you're sitting on. So when Newton says everybody continues to be at rest, he's wrong. Everybody continues to be at dead end, not at rest. Because if it were at rest, it wouldn't move if the obstacle is removed. But we know that as soon as the obstacle is removed, if the body is at a dead end, then it will move. But if it is at rest, it will not move. So, to convince you of that little point, I have a little demonstration, which I showed last time, but this kind of makes the semantic difference between what Newton says as body at rest versus what I say he should have said, body at dead end. For example, I have here 3 toys, spring-born toys or any kind of toys, But are they at rest or are they at dead end? Anybody? Are these toys at rest or are they at dead end?
At rest relative to the table.
No, I'm talking about absolute.
Oh.
I'm not trying to trick you. But right now the demonstration is with respect to table. Are they at rest or are they at dead end with respect to the table?
They're not at rest.
Okay, if they are not at rest, then how come if I move the obstacle, they move? So that means it must have been a dead end, otherwise removing the obstacle, it wouldn't have moved. How about these other 2? Are they at rest or dead end? Let's do the same thing, eh?
You can't know until you remove the obstacle.
Well, I remove the obstacle, but you should still be able to tell the difference if you observe a difference. So I remove it, and this is what you get. So one was at rest, one was at dead end. And you're saying, well, that's just a stupid experiment to show you horizontal movement. We're talking about movement of everything in this universe. I'm saying, no, this is not just with respect to table at dead end, it's also at dead end with respect to the absolute universe. For example, if you remove the table, this bus will go to the floor. Remove the floor, it will go down to the lower level. Remove the earth or drill a hole into the earth, it will go to the center of the earth and get arrested there. And even then, you cannot say that it is at rest because the earth itself is moving. At that time, instead of having a relative velocity with respect to earth, it has the same absolute velocity. And it is moving with the same velocity as the earth is moving, as the solar system is moving, as the Milky Way galaxy is moving, as the local cluster of galaxies is moving, and so on, and so on, and so on. So, what is the point of this little demonstration? Just to clarify in your mind that my disagreement with Sir Isaac Newton is of semantical difference here, but if it were only difference, I would overlook it. But I think in his first law of motion, he made another big mistake. He didn't stop at saying, well, a body continues to be at rest. He went on to say, well, a body continues to be in straight line uniform motion, unless another force is applied, a brake or a acceleration. But that is also wrong. He should have said, a body continues to be in a straight line in a uniform acceleration, not a uniform motion. And we observe everything in the solar system to be moving in a circular or almost circular orbit with a uniform speed, which in physics equals uniform acceleration in a straight line. In other words, if our Earth were to ever break off from the solar system, it would go off in a tangent in a straight line, and it will not be a uniform motion in a straight line anymore. It will be a uniform acceleration in a straight line. So I'm getting behind in my slide, so let's go on to the next slide. And I want to share with you something which is, given a chance, likely to have more impact on our understanding of the universe than did the Newton's universal law of gravitation. And we all know how much universal law of gravitation has contributed to our understanding of our universe, starting with our own solar system. And it has never, ever, under any circumstances, found to be wrong. Minor corrections in here or there, when the orbit is not circular but elliptical. Kepler said so. Newton agreed with him that the bodies, when they are not in a circular motion, they traverse equal area and equal time. So there is a slight adjustment in the uniform circular speed to account for that. But ignoring that, or taking into account, we come to the conclusion that Newton made two mistakes in his first law of motion. One was a body continues to be at rest. Two, uniform motion in a straight line, and they were both wrong. Now, why is universal relationship law likely to have as much impact, given a chance, as the universal law of gravitation? Because it explains everything. Now, if you see here, I have two columns here. This is probably, if you understand this slide, you will understand everything that I have to say after this. Basically, I have a left-hand column, properties of different things, and a right-hand column. Now, the left-hand column, and you can add more things to it, which are consistent with it from your understanding of the physics. And you can add more things to this side also, which are consistent with it according to thing. And then, as long as you're comparing these things in this column, it is a direct proportion relationship. In other words, anything in here is directly proportional. Like, for example, the frequency directly proportional to velocity, clock tick rates, time contraction, aging, plant growth, order, and so on. And likewise here, if you have to, mass is directly proportional to all these entities. But once you pick a property from this, say velocity, and pick another property here, say mass, now you're crossing the columns. When you cross the columns, regardless of which two that you picked, the relationship, instead of being directly proportional, becomes inversely proportional. In other words, the faster you go, the lower the mass becomes, which is just the opposite of what Einstein said. Einstein said, you know, more energy you put into something, faster it goes, and therefore more heavier it becomes. I'm saying, no, he got it backwards. It really becomes lighter. And I will explain to you that. And all the same thing with time dilation. It turns out he got time dilation also backwards. So the only thing he got correct was the length contraction, which also is kind of out of perspective because there's really no such thing as length contraction. It's basically size contraction or volume contraction, which agrees with mass contraction or mass reduction. But anyway, this slide has so much information and affects so much of our physics that I feel comfortable in saying that given a chance, this universal relationships law, which I call God's URL, it's not my URL because mine is still ourpal.com. But this is God's URL, and it can explain so many. I mean, entropy. Whoever bothered to understand entropy? And yet we know that velocity and entropy are inversely related. just as velocity and order are directly related, just as frequency and order are directly related, just as temperature and order are inversely related. But entropy and resistance are directly related. Entropy and mass are directly related. So I mean, you got it direct. I'll give you the mathematics of it behind a little bit later, but you at least see the scope of how many different laws can be derived as permutations and combinations of quantities on left and right side, just remembering same column, direct relationship, cross column, inverse relationship. And it doesn't matter which properties you pick. So let's go on and look at some more. More of my attempt at the poetry, because I think if I can't get the attention of the mainstream physicists, maybe I can get attention of the more creative poets, and they will make some noise for me. My idea is first to create a paper trail, and second to make noise before I die, so that this fear that I have, given enough chance, does really take place. So our physical universe is finite, but virtual universe is not. So those are the two universes that I showed in my color slide, where I said, you know, our physical is just an extremely negligible part of the virtual universe. Less than 0.5%, by the way. Even though in some of the earlier slides they were saying 4% is physical. Actually, it's less than 0.5%. 0.4% is more like it. Anyways, we are slaves to time, temperature, and entropy. These are the properties that don't exist in the other universe. But the virtual universe has them not. Everything is relative in our physical finite universe, but everything is absolute in virtual infinite universe of God. Lower orbit is faster because the distance is shorter. Space station is larger than Galileo's rolling balls. Maybe NASA can measure what Galileo could not, for we have cesium clocks, which Galileo had not. But I don't know if they did. Now here it is, the gamma factor. The gamma factor normally as given is 1 over v squared, square root of 1 minus v squared over c squared. And I'm saying that's unnecessarily violating Occam's razor. This simple law explains it all. One is the range from Vn to c. Vn I call the nominal speed, the natural speed, the speed with which the Earth is moving. And then Vn to c, this formula applies. And on the other side, if you could slow things down, if we could slow Earth down, or if we could slow any object to speed slower than the Earth, which we cannot do on Earth because every object, our experience is limited to Earth, so Earth's motion is automatically part of everything that we move. When I move a couple of inches this way, a couple of inches that way, I'm still moving at the same speed of Earth. There's nothing I can do about that. So, but from the range 2, the formula is even simpler. Range 2 is going the other way. Remember in my previous slide I showed velocity. Now in range 2, you go from Vn to 0. If you could do it. Of course it is as much ridiculous to go from Vn to c as it is to go from Vn to 0. But we're talking about theory. We're talking about philosophy. We are acting like, why is Einstein wrong? And I'm trying to say that. Not that neither Einstein could reach c or 0, nor I can reach c or 0, but at least it puts Einstein's theory of relativity in a slightly better perspective. So again, this is the thing, and let's keep on moving because almost half of my time is up, and I'm only through 1/4 of the slides. So now here it is, a simplified gamma factor, as I say. Okay, this is the left-hand side, denominator is 0, V equals to C on top, V is equal to N, this is natural Earth, that's where we are, and this is V is equal to 0. This is what I called range 0 before, this is I called range 2 before, and these are the formulas, and there's little more math to it, but you have to agree with me. These formulas are a lot simpler than even the gamma factor that Einstein used. So Ux is the value of the unknown element from those two columns, left and right, and X is the speed at which you are determining that, which can be anything from 0 to Vn to c, in theory, even though we cannot achieve speed 0 or speed n. So Vx can vary from 0 to c in this area. It can vary from zero, Vn to 0 in this area, and just the complement of that on this side, and image of that on this side, because directly proportional is inversely proportional on the other side. So it just keeps on. I mean, you can spend 20 minutes on this slide and still have confusion and questions. But idea, again, like I said, my goal is not to convince you that Aristotle, Galileo, Newton, and Einstein were wrong, but the fact that I stood up here like a crazy fellow who said, yes, these people were wrong, this is why they were wrong, here's the mathematics behind it, and I want to leave that paper trail. And after that, we'll see what develops. So let's go on to the next slide. So why do I say Einstein had both mass and time dilation backwards? What did Einstein say? Well, Einstein said that the kind of GPS satellite clocks run slower due to time dilation, but faster due to lower gravity, which is what we used to make the GPS work. And actually, twin ages faster than, more and faster rather than the space twin. And I'm saying just the opposite. No, clocks run faster, both due to lower gravity and relativistic effects, because Einstein had it backwards. That traveling twin ages faster and more than the twin on Earth. So because I say he had it backwards. And now, no, well, why does GPS work if Einstein was wrong? Because the engineers who design GPS systems swear up and down, oh, the GPS works because Einstein's theory of relativity, and so on. No, engineers made GPS work by trial and error. And I know that for a fact. They would take a clock that was going to be put on the satellite and slow it down intentionally and send it. And then see, oh, even after being faster and say, we're still off. They'll wait for the clock to come back or send another satellite and adjust it, again using their judgment and guesstimation and other things, rather than literally calculating how high it is, how much lower is the gravity on satellite level, or what is the speed of the satellite, and how does the Einstein's equation, special relativity, affect that in the opposite directions. And they also acknowledged that the gravity effect was far, far greater than the relativistic effect. And yet still kept insisting that the relativistic effect, even though small, even though in the opposite direction, had what made GPS work. No, science, just fuzzy math, fixed it over after engineers made it work by trial and error. And I think that is a shame in a way. So, not because I say GPS works not because of the science, but in spite of the science. The science was wrong, and the engineers made it work in spite of the wrong science. And here it is. Yeah, it's a compliment to the engineers. Now, let's start with Aristotle and Einstein. And those are the 2,500 years that I'm disagreeing with. What did Aristotle really say? He said, heavier objects fall faster. What did Einstein say? Just the corollary of it. That the faster objects become heavier. But he was wrong. But he was right in the sense that he agreed with the errors of Aristotle. Aristotle said heavier objects fall faster. Einstein reversed it. He said faster objects become heavier. And that's why he came up with this E is equal to mc squared. He imagined in his thought experiment something moving faster and faster and faster and faster. You're putting more energy into it. It has to be going somewhere, and E is equal to mc squared, so it must be going into mass. And that's how they came with it. But I'm saying no, lighter bodies travel faster, or conversely, heavier bodies travel slower. Just the opposite of what Aristotle and Einstein said. And faster objects become lighter. Just the opposite of Einstein. And slower objects become heavier. So this is just a footnote on that. So let's keep moving. Did Galileo prove Aristotle wrong? I presented a whole, half-hour presentation last time on did Galileo prove Einstein wrong? And I came to the conclusion, no, he did not. Regardless of what he did and how many experiments he did not conclusively prove Aristotle wrong that heavier objects don't fall faster. In fact, all he did was he came to another wrong conclusion, and that is heavier and lighter objects, all objects, in fact, he said, fall at the same rate. And that lie of Galileo, that all objects fall at the same rate, we are still teaching in textbook, physics textbook, as if that were true. No. Yes, there are hundreds and thousands of experiments done to prove that all objects fall at the same rate, but there is something wrong with those experiments because it does not agree with the higher principles. Here's by another attempt at poetry. Heavier fall faster to Aristotle sounded right. Galileo thought he proved it wrong, but he was right. Newton taught bodies at rest for uniform motion, but the application of another external might. Faster get heavier, Einstein thought was just right, but faster get lighter came from our pal's mind. Socrates, Aristotle, Galileo, Newton, and Einstein. Who among them, if any, was really right? Socrates and Bruno sealed their testimonies with life, with their own blood. Galileo paid a heavy price, but spared his life. So, let's keep going because I've got a lot of material to cover and only 25 minutes left. So now the question is how much faster? And why hundreds of thousands of experiments done in vacuum pipes and tubes of a feather and a 1 gram stone being dropped, they all fall at the same rate. They both hit the ground at the same rate. Not just Galileo's attempt from the Leaning Tower of Pisa, which the people at the ground told him they fall at the same rate. They all hit the ground at the same rate. How do I explain that? I explain that by this mathematics. I'm saying, yes, the lighter objects fall faster, but only in the same ratio as the ratio of the mass of the Earth to the ratio of to the mass that we are dropping. And same thing with distance. The distance from center of the Earth to the surface of the Earth is much greater compared to the distance of the Leaning Tower of Pisa to the surface of the Earth. So if you apply the mathematics here, and I've got, it takes a little more time to go through it, but it's all in my paper. You can go through it yourself mentally, and you will find out the difference is so small. The difference is so small that even our best experiments, perhaps even with cesium clocks, have not been able to detect that difference. And the reason the difference is small is because the ratio of the masses and the ratio of the distances. In fact, for all practical purposes, in all these experiments, the ratio between the mass of the Earth and the mass of the feather, and the ratio between the mass of the Earth and the 1 gram mass, and then they drop the gram and the feather together, is the same. If the ratio, it's not the ratio between mass of the feather and the mass of the kilogram, but the ratio to the Earth to which it is falling. And of course on Moon, it will fall at a different rate. And you will have lighter objects falling slightly, even slightly faster, slightly less faster than even on Earth. But they're still both very hard to detect. Even with cesium clocks, and I'm not even sure that anybody has really done that experiment since the cesium clocks, accuracy. But yes, they did do lots and lots and lots of experiments before putting it in the textbooks that heavier objects and lighter objects both fall at the same rate. Now, if you like, I will come back to the slide 14, if you remember, and a couple of other slides also, which require a lot more explanation. Each one of them requires at least a half-hour presentation. But in order to give you the full view of it, I want to move on to other slides, and that way we can come back to it if there are questions or if there is time. Or maybe next year we'll do separate presentations on these controversial areas. But right now, I'm not trying to convince you. All I want to do is leave a paper trail. This crazy fellow stood up before us, and he was so delusioned that he had the gall to tell us that from Aristotle to Einstein, they both made the same mistake. And those two mistakes, because they agreed with each other, gave confidence to Einstein's theory also in a way. And yet they both made the same mistake. And everybody else in between was wrong like Galileo, because Galileo did not prove Aristotle wrong. Galileo simply said they both fall at the same rate. No, they do not fall at the same rate. It's a tiny difference. For example, if you take a cup of water and hold it in your hand and ask yourself, is the moon causing tides in the cup of water. A lot of people would say, no, it takes an ocean. No, the reality is that the moon is affecting the cup of water the same way as the largest oceans. But the tides are so small that none of our technology can measure those tides. But there is a difference between the tides on the full moon and new moon and the in-between, even in a cup of water. If you had that kind of technology to determine that small a tidal wave in a cup of water due to moon's gravitation. But we don't. Maybe we are getting there. The cesium talks and the GPS give me hope, but it may or may not happen. So let's move on a little bit further. Again, poetry. I don't know why I got sucked into this poetry stuff, but I think it gives a little relaxation from math and physics to make the same point. And I'm still trying to make the same point I would do in prose, but it helps me. So what do I say? Lighter go faster, and faster get lighter. Or if you enjoy that game on game show in the evening, you know what they call it, game show? You don't watch TV. Anyway, there's a very nice game show, Wheel of Fortune, I think it's called. And they have a type of puzzle called before and after. And if you apply that puzzle before and after to this phrase, it gets shortened to saying, lighter, go faster, get heavier. So you can remove and faster because it's before and after puzzle of the same style. So lighter go faster and faster get lighter, till into the abyss as waves that disappear. Heavier go slower, till they suddenly reappear. Now you see them, now you don't. From quarks and photons to stars and supernovae, hide and seek, they love to play. Which is something that the astronomers have been observing for a long time. So, back to Newton, universal law. Recapping it. Newton, what did he say? In the absence of external forces, the body continues to be rest. What is my disagreement? A body is at dead end due to an obstacle and moves when the obstacle is removed. What's the second error in this? Uniform motion in a straight line. No! Uniform acceleration in a straight line. Or uniform motion or speed in a circular orbit. So, in a nutshell, if I had to summarize, I have so much respect for Sir Isaac Newton that I say I agree with laws of Newton far more than I agree with Einstein's theories. So, 3D or no D. Now this I'm moving into a different area. This is the string theory area somebody has mentioned earlier. And my basic statement here is that in this universe, our physical universe, everything is either three-dimensional or no-dimensional. There is no such thing as two-dimensional or one-dimensional object, space, or motion. And there is also similarly no such thing as fourth-dimensional space, object, or motion. It's all three-dimensional. And if there is a string theory, quantum theory, any number of other theories that are based on other than three dimensions are completely fantastic, brain created by the image of the mind, as the speaker was saying earlier. Those things do not exist in reality. Why not? You can do a simple experiment yourself. Take any three-dimensional object in your hand and imagine that any one of these dimensions, and you can take your pick, which dimension you pick, that you're going to reduce that dimension. And you keep reducing it. Not to infinitesimal, which we don't know what it is, but to zero. And as soon as any one of the three dimensions goes to zero, the whole object vanishes. The other two dimensions cannot exist without third dimension, regardless of whether it is space, whether it is an object, or it is a motion. Now what do I mean by motion? If you look at it, if I throw something in a straight line, it looks like, in a way, one-dimensional motion. But it is not, because the entire motion of the Earth is being imparted to the ball also. And since the Earth is moving in a three-dimensional motion action, which is rotational, orbital, linear, and so on. All of those components are part of when I throw a ball in straight line. So you're watching a baseball game. Comes in very clever, strong, best pitcher, and he throws a ball. You say, oh, he throws it in a straight line. Looks like a straight line, so it might be linear. And then you find out, no, it just looks linear because the gravity had very little effect in that short distance to go down. But you know in reality that the gravity did pull it down a little bit, even if we couldn't see it. So it's two dimensions right there. Then the next ball he throws is a curved ball. And the curved ball, rotation, just like the rotation of the Earth, eventually changes the path like the yaw of a plane. So the curved ball, confuses the batter even more. And now you've got all three dimensions of the motion, even without considering the motion of the Earth being imparted to it. What I'm saying is, no, you can imagine a linear, one-directional motion on planet Earth. But that still does not make it one-dimensional motion, because you must impart the motion of the Earth to it also. Otherwise, you're just fooling around with relative motion. And all of my work here deals not with relative motion, but absolute motion. So let's keep going. So did I tried to do these conclusions in here, and I think I have explained them as well as I could. So let's go on to the next one. Next one, again, little poetry. 3D or no D, string or quantum loop theory cannot be. 2D or 4D is fantastic quantum leap of mind to be. Like Footloose and Fiancé Free, all non-3D theories, by definition, are fantasy and therefore all fact-free. So, fact-free sounds like something good, but I mean it's something negative. You know what I mean? So, but I'm trying to leave a obnoxious paper trail in a pleasant manner, if there's a way to do it. But I am being obnoxious, by saying statements like Aristotle was wrong, Sir Isaac Newton was wrong, Einstein was wrong, Galileo was wrong. Where am I going to stop? Is this guy lost his brain? Or is this, what's he doing? Or am I hallucinating, like he would say, if I'm creating it, Which is a small possibility. I don't completely rule it out. But at least I want to take that small chance and say, hey, okay. Gravity is another area. Like I say, like this universal law of gravitation, this universal relationships law will contribute, given a chance, more or equal understanding of our universe as did the universal law of gravitation of Sir Isaac Newton. Okay, so gravity. I say gravity is a local physical contact force of virtual particles. There's nothing local about it. It's not some spooky action at a distance. It's not non-local. Okay, now all IEVU iterations, including electromagnetic radiation, in our physical universe are through virtual particles such as photons, neutrinos, and electrons and others. And that's why now you see them, now you don't. Again, you're going back to the speed. The closer a particle is to speed of light, faster it is moving and lesser mass it has. And that's why many of these subatomic particles, now you see them, now you don't. Now you see they have a mass, then you say they don't have a mass. And all those disagreements, because you are penetrating at the verge of C. And at that speed, according to that table of left and right column, which you see, the mass becomes zero. Unlike Einstein, who would have said no, at C is equal to, V is equal to C, the mass becomes infinite. No, it doesn't. It becomes zero. It does become infinite. Mass does become infinite if you reduce the speed to zero. But reducing the speed of the Earth to zero, you cannot do unless you also reduce the speed of the Virgo cluster, the local cluster, the Milky Way galaxy, the solar system, and all these complex three-dimensional motions. Unless you can reduce all of them to zero, you will never be able to prove me wrong because you've never achieved that thing. So in some ways I'm saying that I cannot be easily proven wrong. Of course I cannot be easily proven right either, but that's neither here nor there. So let's keep moving. How am I doing for time? I got 10 more minutes. would you rather go through slides or ask questions? This is a gravitation thing about how something dropped would get arrested into the center of the earth, and this is the mathematics behind it. And there's, of course, a lot more mathematics than I can present here. Some of it is in my paper. So how much does the universe weigh? This is a very good question. And I have been able to calculate. You can't weigh, but you can calculate it. Now we're talking about the mass of the entire 0.4% physical universe, which is part of the infinite space universe. How much does it weigh? Many want to know, how much does the universe weigh? 100 orders of magnitude greater than 1 gram, I say. So you take 1 gram and multiply it by 10 raised to the power 100 grams, and that's the mass of the universe. Not just the mass of the solar system, not just the mass of the Milky Way, not just the mass of the, all the stars and physical stuff, but of the entire universe. Whether on Earth or Moon or on Jupiter, it matters not. Well, you say, well, how can you say? It doesn't matter whether you're weighing the universe on Jupiter or Earth or Moon, because the gravity is so different there. Because 10 orders of magnitude, 100 orders of magnitude, because 1 order of magnitude tolerance covers them all. So worst comes to worst, I'm saying 10 raised to the power 100. So it could be 10 raised to the power 99 if you went to Pluto, or 101 if you went to Moon. But Moon is still only 1/6, not 1/10. So I'm still safe. So, yes.
But it's moving.
It is moving, so you can't stop it, right? And these experiments are not practical. So I'm not worried that somebody's going to. Here is how I think the gravitational contact force works on our planet Earth. It has 3 components: tangential, UVLMX, radial, UVLMN, and the diagonal, which is the resultant, which provides the orbital motion, is the diagonal combination of UVLMN plus UVLMX. And these components you can calculate relatively. So Schrödinger had a cat, both alive and dead at the same time. It's a wave, it's a particle, no, it's neither, or maybe both. The naked fact is, it travels this wave and teases as photons. All electromagnetic radiation travels as waves and interacts with physical as virtual particles. Like this magnet Electra, it's slim, trim, smart, and sleek. Now you see it, now you don't. 1 feet of it's 2 feet. A lot more to cover, so let's go a little faster. Light. According to Schrödinger and quantum mechanics and everything, light is never both wave and photons at the same time. Even though they say the dual nature, well, it's both wave and photon. No, it's not both. What light is basically, it interacts with our physical universe through particles. In other words, why is it that you're able to see anything? Now this is going to take off on what Don said earlier. The reason you are able to see anything is made up of 3 things. One is you need the brain. Well, one is, I should say, you need the eyes. You take a blind person, he can't see. So you need eyes. Then if you have a moron, the eyes alone can't see either. So brain and eyes are not enough to see anything. You need light. So what's the role of the light? Light, which is waves, not particles, becomes photons to interact with anything and everything physical. And it does not become particle until it comes in contact with something physical. And why must it do that? Because there's no other way for you to see. When the light from the window comes in, hits this table, it becomes photons and re-emerges as speed of light again. But this time, now it has collected the information by interacting with the table through photons as to the shape of the table, color of the table, the perspective, the size, and a whole lot of information it has collected. And if it weren't for the fact that light had to become photons and gather that information, because when it left the sun, it did not have that information about this table. But when it came through the window and hit the table or the computer or these slides, all of these put together made the difference. In other words, photons helped pump information about the physical world that it came across on the way into the wave, which went into our eyes, which our brain processed, and we got the image of what we think is reality. So, Miss Mag Electra, did I say that? Didn't we go through that already? So, lighter, go faster. What is this? This seems like the repetition of the same thing.
It
Right?
is.
So that's, I mean, sometimes it may be a different poem, but sometimes you get different moods, so the poems come out a little differently, but the essential truth is still the same. Now, this is a whole new subject, and it's 5 minutes to 2. Maybe I should leave a few minutes for questions, but this subject is very complex, and if you can believe this, now, if you thought my first part of the physicist presentation was controversial, this is certainly several orders of magnitude more controversial than what I have presented before. In fact, this is so controversial that I wouldn't be surprised that somebody would take a gun and shoot me. They say, hey, there's only one way to get rid of crazy people like him, is to shoot him. You know what I mean? But so, I don't think there are any crazy people like that here, but at least I want to say that yes, I do have this bi-Trinitarian man concept, that is a man is made up of 6 different levels. And again, I'd rather not say the controversial statements, but just holistic poetry here, a little bit about body is body and soul is soul, brain is brain and mind is mind. Mind is that part of the brain which goes with me when I die. Soul is spirit and mind is intelligence as it appears surely to me. But amoeba to Asija is neither religion nor good science for me. If you believe what you will, but what I believe is only up to me. Someday we'll know who is right, but be it you or she or me. Body without soul is dead, as soul without body is helpless. Brain without mind is useless, as brain without mind is limited. Or as mind without brain is limited. Mind without intelligence is misleading, but intelligence with mind and brain does it all. So, this is a slide that shows up much better on an overhead projector with my animation, because this is all full of different motions and stuff like that. So, but I could not carry all that weight, so at this time I brought only the PowerPoint, just for the weight. Because you know what the airlines are doing now? If you check 2 bags, for the second bag they want $40 or $50. Used to be you could check 2 bags with your normal fare. So they're getting greedy. So, political inertia of the science. Science and politics are joined together at hips. Where the money flows, the science goes, and where the science goes, blindly the money flows. The cycle is not easy to see, let alone break. So people ask me, the reason sometimes you're successful is because you are a yes man. I said, no, I'm not a yes man. When my wife says no, I say no. Now, if you have something like this, am I a yes man or a no man? Is this a yes or a no? But that actually accurately reflects my thinking. There are 5 types of scientists. Those who don't know and don't know that they don't know, they are naive. Nurture them. Those who don't know but know that they don't know, they are learners. Mentor them. Those who know but don't know that they know, they are asleep. Wake them up. Those who don't know but think that they know, they are dangerous. Avoid them. Many of them are mainstream physicists. Some even Nobel laureates. And then those who know and know that they know, they are real scientists like Aristotle, Galileo, Newton, Edison, Tesla, Marconi, Einstein, perhaps you and me someday. Anyway. So I think I better stop here because it's almost time. Well, there's more poetry, more slides, more everything. But I asked for 1 hour. I was lucky to get it because originally I had asked for only half an hour. And now I know next time either I have to make more than 1 presentation or ask for at least 1 hour and a half. Or just skip. Not come to the meeting at all. So those are my options. I think, so there is, I don't know if there is a couple of minutes for questions since we started a couple of minutes late. Yeah. So who wants to ask the question anything other than telling me you're crazy? Because that I already know. And I can read your mind you're crazy.
I got one thing.
Yes.
You said there are many things that I would disagree with, but there was one point in the presentation that maybe I could agree with, but it wasn't quite presented clearly, and that had to do with the weight and the feather
falling, yeah, in a
Yes.
vacuum.
And you spoke of the ratio of the mass of the feather or the mass of the ball in relation to the earth.
Right.
Now, I think what you're really getting at is that if you consider any falling weight in the earth, you're talking about a two-body system, the total mass of which is the sum of the earth and the mass
Right.
of whatever's falling, the feather or the ball. So it isn't both of them being ratioed to the mass of the earth. They're being ratioed to the sum of the mass of the earth and itself. So they are different in that respect.
Yeah.
That's the difference that I see.
And that's what my math will show. And same thing with the distance.
But that
No,
was,
that's because I was rushing. I didn't even have a chance to read through the math. And if we had gone into that, we would still be here discussing that slide. But here's the point to remember on this, that Newton, in his universal law of gravitation, should have stated not product of the masses and the distance square, but he should have said product of the masses and the product of the distances. And since the D1 and D2 happen to be the same in two-body system, he just called it D squared. But in reality, if you take her approach, that you apply to 3, 4, and multiple bodies, then the universal law of gravitation should be stated product of the masses divided by the square of the product of the distances. Even if that distance is same for any two bodies. But when you go to three bodies, the distance isn't the same. No, yes, there's a lot more to it. This is another, danger you have of incomplete time, incomplete statements. You skip some, you add some, and you never know how erroneous it is becoming, so on. But I think the point is still there, that everybody between Aristotle and today still believes all objects fall at the same rate, but they don't. The difference is small, but not to be ignored as far as pure philosophy and pure physics is concerned. In practice, yes, you can ignore it, because in theory there's no difference between theory and practice, but in practice there's no similarity between theory and practice. So you see,
that's about all the time that we have.
yeah.
And I'm sure we'll be discussing this again in